in this video, we will show you how a mic can be plugged into the Arduino board where it'll send data into Grasshopper, and how this data can be fed into a hexagonal shape in this case, in a pattern of a wave using the fader. And by speaking to mic, it can slow down the movement of the wave. And here we have is the Arduino board, a basic setup where the mic is plugged into pin A1. So now we've finished the Arduino setup. We use part available to show which part is actually plugged into our computer. And here we have is part 7. And just type it in and put it into open pot. And to open the pot, we just need a toggle, and just use another panel to plug into message. So it'll show hooray, it's successful when you open a pot, if there's no error. And here we have is mega read, which is especially for this Arduino mega board. And same, using a toggle to start and open it, and just select the same part. And since we are playing with time here, we'll also need a timer attached to receive the data. And as the info, the analog info we're getting is from 0 to 1023, so we need to change that in the S. And in T, we can roughly change different domains. And so here we're just remapping the data from pin 1. And because there's too many ambient noise, so this is why we need to use the smooth component. And so the more you have, the bigger the value of n is, the more it will sort of take the average of this data. And now we'll just use different hexagon forms and just apply it onto a surface to demonstrate how sound can sort of be an input in the sensor. And fader, this is another new component in Firefly, where you can input in V and V1 and V2. That is the minimum to the maximum value. So essentially it'll just move from V1 to V2 for whatever you define. And T1 and T2 is pretty much the speed, and you'll also need a timer for it. And now we just attach it to a point in X, and then just drawing a line so it'll move in the direction of Y. And just using a curve and line intersection between the hexagonal shape and this vertical line, we can define the different points. But yeah, we need to graph it first. And also about fader 2, it moves back and forth, whereas another similar component is fader 1. it just moves one direction, and it can be repeated over and over again. And now we're just using this line produced by the fader to see this point, the closest hexagonal shape that's closest to its line, and how it can create a sort of wave and variation when a certain sound is applied, is detected through our sensor. And so we will demonstrate this by moving the hexagonal shape up. So this is a pretty straightforward exercise. Here we have it. Just to create a wave pattern. So now we just turn on our pulse, and now the fader stuff, it just moves back and forth. And when I speak closer to the mic on my Arduino board, as you can see in the graph, the line, it gives a bigger value, and so on the fader itself, you can see the movement is slower here. That's how I set it.